And I'm going to deal with, first of all, roofs and then windows and doors, the resiliency. So, and again, my name's Terry Ort from Domus. Resiliency is defined as the ability to absorb or avoid damage without suffering major damage or failure. That's why we want to build resiliently. It should be the objective at the design stage, the maintenance and restoration for buildings, as well as infrastructure and for communities as well. Now, from my experience in the construction game, I've found that many homeowners and their contractors either don't have the required knowledge to build resilient buildings, or they choose to cut corners. Could be the contractor cutting corners, the homeowner doesn't know. Or it could be that the homeowner makes some very short-sighted decisions and then pays later. So from what I've seen, with all of the problems that have occurred potentially down the road, sometimes people doing things over and over 2 and 3 times, I really recommend that homeowners retain a professional to fill in the knowledge gaps and ensure contractors do the right things during construction. So firms such as Mikey's is absolutely ideal for this. And I guess if he doesn't have time, he could probably recommend some other people. As far as the windows and doors, we have trained our team, and we actually provide a lot of consulting assistance to go over the questions that should be asked to try and make sure that the windows and doors that people choose are in fact resilient. So if we look at resilient home construction as it relates to roofs, you'll see this particular photograph is 1,000 words. This house has its roof on and everything else is wiped out around it. So obviously they did the right things and it can be done. So in terms of what is a roof, well, I think everybody knows a roof's a structure that forms the upper covering of the house. And these tend to vary quite dramatically from one region to another. And they're influenced by a number of people, including the homeowner. And very often, number one on the list, not 7, is the cost. And so it is certainly a consideration, but the other things should be taken into account as well. So many homeowners are enchanted by the roof design of their structure. And often this enchantment can make decisions that are not really very well made, and they cause a lot of hardship down the road. So in terms of choosing the type of roof, I'll get into that in a bit, but there are very many different types. Flat roof, there are stages particularly for large multi-story apartment buildings and so on. Flat roofs make sense. Gabled roofs are very, very common out there because they're simple to build and design. Hip roofs are a little more complicated, actually can do a lot better job than just about anything else. Some of the camber roof and the shed and conical, all these other ones are not used that often. So integral to a roof, we can have either roof trusses to hold up the roof, or we can use rafters. The roof truss is a structural framework element designed to bridge the space above a room and above really the top floor, and then support the roof. These usually occur, and probably should in most cases, be there at regular levels to create bays. And then the distance between those will depend upon the design of the roof. Should never be more than 3 feet. There's some pluses and minuses to rafters. Rafters take longer to install on site, but they're going to require more time. Also, the lumber for rafters can be cheap compared to trusses, although this is now no longer always the case with the price of lumber having gone up so much. And trusses are a little more complicated to install, but less time to fabricate on site. The amount of on-site time is much less. So the trusses need to be able to be designed to take the worst possible combination of dead load and wind loads. And the individual truss members are designed to take a certain portion of the weight, And depending on which elements, they're either in compression or tension. These, you see all of these have triangles to them. And one element of the triangle will always be in compression. The other will always be in tension. The webs that form the small triangles strengthen the overall structure. A triangle is extremely stable and is a very fundamental part of construction. The loads on the individual webs can be in tension or compression, as I mentioned before, depending on the type of load. The other thing too, a lot of roofs will have purlins to them. Purlins run horizontal to the walls and perpendicular to the rafter, and they very often form the fundamental support for roof sheeting, and the roof sheeting is then attached to the purlins. Now they can be in kind of a C-like shape or a Z shape. Material that's used depending on the roof loading and the spacing and so on, the location of the building. And so the variety of different, again, we really need to rely on somebody who knows roofs, because roofs are extremely complicated to the average layperson. They shouldn't be welded. The purlins have a number of advantages, very often saving in construction costs of up to 30%, and a reduction in weight and less weight to bring to site as well. Now, the sheeting materials can be made out of a number of different. Yeah.
Sorry for interrupting, but I think there's a point that I need to make.
Okay.
On the roof construction side of it, we have a lot of unqualified people actually fabricating house roofs, and they're using these 4x2 I-beams as rafters. These sections also were not intended to be welded. They're not really for structural work. The smallest member approved for being used as a roof rafter is a 5x3 9-pound beam. And these 4x2, they also break very easily when welded in position to form a roof. So I just needed to say that.
The weld can also corrode. And yeah, you're right. I mean, that's why I say we really need a professional, and you need someone to make sure that the contractor knows what he's doing, and actually does it. So roof sheeting can be made out of a number of materials. A lot of them are alu-zinc, galvanized. There's some other types as well. Clay tiles are not nearly as common here, but asphalt tiles are certainly, asphalt shingles, pardon me, are used in many cases as well. The thickness of the roof sheeting material is very, very important. And if you look at it, the higher the gauge, the thinner the material. So 28 gauge is the minimum thickness that can be used, but shouldn't really, I think it's really too light to be used reliably. You can use 26 gauge here in Trinidad. 24 gauge is recommended in high areas, and if there's hurricane risk, you should really be using 22 gauge material. Now, Maggie was talking about the way in which the roof rafters or joists are attached to, pardon me, or trusses are attached to the walls. And obviously, if they're not properly attached, he mentioned before, you don't want to stick a couple of nails in to try and hold it in place, because then it's just sitting there waiting for a storm to come by and disappear. So these are very good examples of how not to do it. And unfortunately, it seems to be done a lot in this way. Instead, what should be done, whoops, is this the best practice? Oh yeah, this is our nails. I must have repeated this one. So what we really should be doing is using hurricane straps that are tied to the rafter itself. And then those in turn are anchored down into the ring beam in order to hold it in place. And notice it goes right through the 4x4 at the edge of the roof. So this is another method. Basically, what you want to do is make sure that you tie your rafters into the ring beam, which in turn needs to be tied into the wall so that ultimately you end up with the roof being attached to the foundation through the walls. Here's a good example of a ring beam where they did put a bolt in there and then didn't bother tightening them. So if a windstorm comes along, this particular one, which Mikey actually saw on site, um, and also there's no washer, the nut could actually maybe potentially pull through the hole, but you're going to have the roof lift before it hits the nut if the nut doesn't come off. Now, wind is one of the real worries, probably one of the major worries on roofs. You also can have dislocation of the roof during an earthquake as well. But if we look at wind for a moment, then the wind force is naturally going to push against the wall on the side where the wind comes from. Also, as it goes up and over the roof, it's going to push the roof section down towards the center of the building. And then as it comes up over the top, it creates kind of
immediately after this webinar. We'll be contacting.
just a minute, Ayana, I think you're you turn your mic off. So anyway, as mentioned here, what happens, this almost turns into a bit of a wing on an aircraft, and it creates suction and it creates lift and it wants to pull the roof off. So if it's not properly attached, then this can lift right over here. This will tend to be pushed down on this side and the roof will come off from here. And then you're also going to see some pull on the walls, although if the walls are properly constructed, that's not really too much of a worry. Now, you might have heard of roof pitch. Whoops. Pitch is really the steepness of the roof itself and how much of the rise is there versus the run. And in terms of the roof pitch, depending on what the angle of that roof is, you can actually get suction forces pulling it up, or if it's a very steep roof, you can actually have the wind forces tending to push it down and causing it to failure. So pitches of 30 degrees are suction. Actually, 30 degrees is about the break-even point, and that's really the ideal roof. So here's an example of a roof that didn't get through Hurricane Ivan, and so that really can show what can happen. In many of these cases, the roof did not need to go. So what makes buildings more hurricane resistant? First of all, multiple slope roofs. In other words, hip roofs are better than gable roofs or others. The overhang should not be more than 20 inches, pardon me. Sorry. The roof slope should be about 30 degrees. And steeper than that, as I said, you're going to get downforce. And less than that, flat roofs are very susceptible to lift and can be lifted off. You need to properly attach the roofing material. The sheets need to be attached to the purlins properly with screws, not with nails. And then the roof and walls need to be all tied together and ultimately the weight tied into the foundation. Now, in some cases, to retrofit, you can actually use interior galvanized cables that are attached to the roof section. So if your contractor did not attach them properly, then you may have to do something like this. The other thing too is to install hurricane resistant windows and doors to prevent the hurricane winds from blowing buildings apart from the outside in. And I'll go into that in a few minutes. So I'd like to run a roof poll now and see whether people have picked up some pointers. So what roof type is most resistant to wind damage? What are the advantages of using trusses? The advantages of using cold rolled purlins, the C or the Z type. And then what gauge of roof roof sheeting should be used in a hurricane zone? Okay, maybe just another minute. I don't know if people are answering. Okay, maybe just another 30 seconds or so. Still a few people answering, so we'll wait just a few more seconds. Okay. So in terms of the roof type that's most resistant to wind damage, it is the hip roof. Gables, depending on the angle of the wind, can create turbulence around the end of the roof. And if you have the multi-faceted hip roof, it's by far the most resilient. In terms of advantages of roof troughs, again, people picked one or the other, but it is all of the above. They can be installed more quickly. They span longer distances and can be made more robust. They're less skilled to install on site. And so all of those are applicable. And again, the same advantages of cold rolled purlins. All of the above are again correct. And for hurricane zones, you really should use 22 gauge. You certainly should not use 26 or 28. And even 24 gauge is in windy areas, built on mountainous areas or so on, would be more appropriate even if you're not in a hurricane zone. So thank you for that. And now moving on to the resilient home construction as it relates to windows and doors. Now, what do we mean by resiliency as far as windows and doors? Well, first of all, we want to make sure that they perform properly over time without any deterioration. Again, most people don't like doing maintenance. It's costly and so on. So we just want performance over the long term. They obviously need to keep the water outside from rain, and they need to have wind resistant. Even if there are infrequent hurricanes, I'll show you in a minute that Trinidad has had its problems. Even if they're not a full-fledged hurricane, you want to make sure that the windows and doors do not fail because they start a cycle. If there's flood risk, then you really want to look for flood protection from your main entrance door. And go into that a little more. Security and impact resistance. There's a lot of crime in Trinidad, and that seems to be getting worse, if anything. Energy efficiency, reduce the cost from that. They should look good and continue to look good. Mikey was mentioning sound. There are ways to dramatically reduce the sound in your bedroom, and then obviously there should be reasonable cost. Notice I didn't say the lowest possible cost, because if you want to get resiliency, you're going to have to spend a little more money. And I know I've been under pressure as the CEO of Domus to cut our costs, and we've lost a lot of business because people have found cheaper products out there. But I've refused to do that, because by doing that, we would affect resiliency. And really, the reason I started the company was to provide resilient products that are going to basically last forever. And if anybody, if suppliers want to supply just the cheapest stuff, well, okay, but not from Domus. So in terms of functioning for the long term, you have to choose the right material, and it really does matter. First of all, wood has been predominantly used over the centuries, and really has it was used in the Caribbean as well, but not so much anymore. It's got a lot of problems. They deteriorate, rotting, termite infestation, twisting, require continual painting, provide very little security. The wood is generally very easy to split. And just as it can split from a thief attempting to get in, also hurricane impacts and wind load can also affect them. So wood doesn't make much sense. And this is North Coast, less than 2 years after the homeowner moved in. Maybe he thought he was saving some money, or maybe his contractor saved some money. But within 2 years, he had to take them all out and replace them again. So rather than doing it right the first time, he paid the first time, he paid to take them out, and then he paid again to replace them. This is the Magdalena Hotel after a few years, not very attractive. And this shows what happens if you don't do the maintenance. Again, not terribly attractive. This is in St. James. Steel also has a number of issues. There's no accepted standards anymore for how they're to be fabricated or coated. They look, by current standards, look pretty rough and clumsy. They rust quickly, require continual maintenance, don't seal, and conduct an awful lot of heat in making the energy efficiency really unsatisfactory. This again is Magdalena, and you can see rusting. I've seen these windows. This is from Canada Hall in Ewie, and so you don't have to be on the east coast of Tobago to see a lot of deterioration of metal windows. What happens, Mikey was talking earlier about spalling. Water gets into the steel, expands to 7 times its volume. As it expands, it puts pressure on the glass cracks and eventually pops out. So there's a lot of aluminum windows in the market, and they do have a number of advantages. They're really aesthetically pleasing. But the big issue is that they're very easily manufactured. Basically, if you've got a saw and a screwdriver and a measuring tape, you can make an aluminum window or door. It requires very little skill. There's wide ranges of colors and so on. And there are aluminum manufacturers in almost every island in the Eastern Caribbean. Also, people are very familiar with aluminum products, and the entrance cost for UPVC was much higher, and still is. In fact, to get into UPVC costs a lot more capital. So few quality manufacturers are around to compete against them. Historically, they've been less expensive, less labor, smaller factories, and so on. But with aluminum having gone up in cost so much in the last couple of years, that's probably no longer the case. But they do have a number of disadvantages, which is why I didn't get into them. The exposed aluminum corners, when they're cut, they oxidize and erode. Also, you get electrolysis between the steel screws, and the aluminum tends to erode. The corners, are cut to raw metal and sealed, but the seal eventually breaks down and they eventually leak. If they have rubber gaskets, then the Caribbean heat and sun shrink and crack them. And so then you're having to do maintenance, take all the gaskets out, replace them. Should ideally be done with every 3 to 5 years. Also, if you've got gaskets, then they have no security whatsoever. Even if you're using laminate glass, all you need to do is give one crack, the glass cracks, and so it then relies on the interlayer of the laminate, and that becomes very flexible and be kicked in. So a thief can take a hammer, hit it once, and then kick it in and be break in within seconds. The other thing too, there's poor thermal performance, much like the steel. It does conduct heat, and so there's a number of disadvantages. This again was Canada Hall in the first renovation they did. This was within 9 months of a renovation. You can see now that the gaskets are starting to twist, and just about all of the sashes were within 9 months leaking, and therefore would have had to been done again. These are corner indication of the corner oxidizing. If they're white, you may not see this much, but they will be corroding over time. And then since the corners are not welded, then you can have this splaying and again leaking. So the reason we got into UPVC was that they very clean lines and classier than a lot of the other products. They're totally inert. There's no corrosion, even in high salt concentrations or dust, or even next to a cement plant, you won't find any corrosion. There's no maintenance to speak of, no painting, very easy to clean. The corners are welded so they can't leak or deteriorate over time. They carry the longest guarantee. You'll find that aluminum windows are not guaranteed for very long, whereas with UPVC, you can get a 20-year guarantee. And the other thing too that's very important, they have excellent thermal performance. They don't conduct much heat and therefore they reduce the air conditioning costs. Now, there are some disadvantages. The primary one is that the equipment required to produce them is far more expensive. It has more steps to it. I would estimate 10 to 20 times the amount of capital to set up a proper UPVC window plant relative to an aluminum one. So it requires more investment, and that cost has to be amortized over time. Now, historically, the highest quality UPVC material has been more expensive than aluminum or steel. But in the last 18 months or so, that's no longer the case. There are a limited range of colors, although 80 to 90% of the market are still white. For those people who do want other colors, they tend to be very trendy and maybe great right now, but 5 or 10 years from now, they're out of favor. And if you've ever seen a green toilet, you'll know that somebody at some point thought that was really cool. So those are some of the potential disadvantages. Now, before I get into some of the problems with windows and doors generally, let me remind everybody that Trinidad is not exempt from hurricanes. There was one in 33 that killed 11 people, another one in 63 that killed 18 people, 74, Alma killed a couple of people. And then we've had numerous other storms that cause a lot of flooding, if nothing else. So if you look through the archives, you'll see some of the devastation that has occurred. And even if it doesn't happen very often, all you need to have it happen is once in your lifetime, and you can be totally ruined. So these are some of the examples of the hurricanes in the past. Oops. Now, in strong storms and hurricanes, 80 to 90% of the roof failures are preceded by a window and door failure. In the first case, you can have flying debris. So if you don't have proper ability to withstand missile flying around, then it can knock out the glass. And or in this particular case, it's obviously a wind load failure. In fact, wind load for the strongest of hurricanes is the most destructive part as far as windows and doors, and then followed shortly thereafter with the roof disappearing. Even if the roof's put on properly, it's not going to be able to withstand it. So this shows you the wind load per square foot. You can see it goes up at the double the rate of the wind speed, and so it as you get higher and higher, the load gets much greater. In fact, with Irma and Maria, the strongest hurricanes that we've had in the last while, and Dorian, you're approaching almost twice the amount of load on the windows and doors and the wall structure as you are on your floor. So what that can mean is if you've got a patio door, you can end up with a ton, 2 tons, 3 tons or more of weight on that particular structure. And if it's not properly designed, it's not going to survive. But the more interesting thing is once you lose a window or door, then the hurricane or windstorm itself can get inside and pressure builds up. And as you can see, 1,000 square foot roof, which is not a huge house by any means, even at a 50-mile-an-hour wind, you've got a considerable amount of lift, a couple of tons of lift. As that gets, wind speed goes up, you can have thousands and thousands and thousands of pounds, which is why in most cases, roofs fail in hurricanes and strong winds, not because the roof fails, but because the windows fail. Now there's 3 basics that really need to be taken into account, actually 4 if we take it, but in terms of the construction of the units themselves, if you want to make them hurricane resistant or even high wind load, first of all, the windows themselves must have frames, mullions, sashes, and so on that are strong enough to withstand the highest wind speed. And as I said, if we do get hit by a bad hurricane, then the wind loading could be more pressure on the windows than on the floor. The second thing is the glazing must be resilient enough to survive multiple missile strikes, flying debris, and the same thing is true for security as well. You want to be capable of withstanding the forces and making sure you keep either the wind and the missiles and so on the outside or the thieves as well. And the last, which is very important, is to have the glazing secured to the frame, because once a missile hits the laminate glass, it becomes very flexible. And if it's not secured to the frames, it'll simply pull out, which is what happens with rubber gasketed windows. I mean, in St. Martin, we saw thousands and thousands and thousands of glass that just pulled out from the rubber gasketed windows. So they need to really be glued into the frames with strong waterproof adhesive. So that's the construction of the window. But the other thing too is installation is absolutely critical. And if they're not properly installed, then again, they can easily disappear. So first of all, the fasteners need to retain their strength of the life of ownership. Now in the Caribbean, I've seen many, many, many windows with regular steel screws that are totally corroded and or disappeared entirely. Why is that? Well, we put the window in, we caulk on both sides of it. It creates a nice chamber inside. With humidity builds up. The screws we do put in create concrete dust. And so the you've now got a soupy material that is going to eat the screws. So they need to be high grade stainless and preferably coated to be impervious to any attacks. The fasteners need to be all around the perimeter. Again, we saw in heavy winds very often that there were not enough fasteners and one corner or another came loose and then everything went from there. Also, the fasteners need to be long enough. We require 3-inch long screws and they must be at least 1 inch into the structures so that when the pressure is on, they don't bend and pop out. And the other thing is to use high quality 100% silicone caulking, which adds to the adhesion and resistance to wind load, but more importantly, does not break down and should last for 50 years. Whereas a lot of the other stuff you buy in your local hardware store will start to dry out and start leaking within 2 or 3 years. So silicone is more expensive, but it might cost you $10 or $20 more for the installation of a window or door. But at least you do it once and then that you shouldn't have to touch it for life rather than to do maintenance every 2 or 3 years. Now, the windows I mentioned should be capable of surviving impacts, whether that's from a break-in or wind-borne debris. And three of the glass types that are often used are tempered, regular float glass, or laminate glass. Now, tempered glass people say is stronger, and it is true. Tempered glass is stronger until it's not, and you'll see that in this video. So one shot and the tempered glass is gone. So that's laminate glass of an adequate thickness. And you may have seen this during the prelude. This is laminate glass that is not adequate. And it's sold in just about every island up and down the Caribbean. Pretty much the same stuff, manufactured in China at low cost. And it does have some laminate, true, but it doesn't really do the job as far as windows and doors are concerned.
This is for you. This is your glass. We're gonna test it. This is the treats. How you feel it? You feel
Oops.
then good, we will find out. Right through. Look at that. Hit the thing going right through, man. Stop. Laminate glass. We're gonna try to hit this.
So this is the homeowner doing some tests before he buys his windows, doing his homework, checking for resiliency.
This is no good, man. That's one. It mash up. That's the end of that. It mash up.
So if you're going to put that kind of laminate glass in, it's almost useless.
It must take 10 shots of this hammer to pass. Nigel, you ready? Let's go. Good. 2, 3, 4, 5, 6, 7, 8, 9, 10. Nigel, you pass.
Yeah, so that's shows the difference between the different types of laminate. Now, there's ways of testing. This is actually in a laboratory. This is one method, ASTM standard, 3 blows with a 2x4, 4 feet long, shot from a cannon at 50 feet per second. And you can see that after 3 blows, the window gets pretty cracked up, but it's still, if it's a thief or the elements there on the outside, and that glass can be replaced without any real permanent damage to the window.
Try again. You're not getting in very well.
Yeah, so that's the high impact stuff, and as I said, you can see the 3 different grades of laminate glass. So wind and impact damage are one, and also security is also an issue. So if you want to be secure and also not have failures from wind and hurricanes that could in turn result in the roof being lifted off, regardless of how well it's constructed, then it gives you some indication how to get resiliency. Oh, I just realized I haven't turned on my video. I'll do that just to prove that there is somebody behind this. But interesting, in flood damage is probably more prevalent in Trinidad than anything. 2018, I went through down the road, drive, in a bus trying to get through the water over the road. Overall, that was about a $2.5 billion. I visited a number of the properties and they were totally destroyed. Appliances ruined, ground floor furniture, interior finishes, and so on. So just about every home in a low area got flooded, and residents had to move out, in many cases for a long period of time. A lot of dislocation, a lot of cost. And so again, for those people, if they only had realized that there's some basic things they could have done, even if there was going to be flooding, that would have mitigated that damage. And so, but they didn't do it, and there's still people now still building homes in the same basis and still ignoring the risk. Not maybe they haven't selected, they're still not selecting the right sites, as Mikey was talking, or they already in homes where they shouldn't have been built in the first place. So what happens? Typically these floods are up to say 2 or 24 inches, 30 inches, 3 feet. I mean, in some cases you can have them deeper than that, but typically for what I saw anyway, probably 80 to 90% of the flooding is not any deeper than that. So if you put a back valve, check valve on your sewage to make sure it doesn't come in through the septic system, and you also seal off any holes that are below the windows that might let water come in through the walls, so very often electrical or other things, not that hard to seal up. And then the third thing is your entrance door or doors really should have flood resistant doors. Now we actually tested our door, and this shows water flooding of over 30 inches. In fact, it went deeper than that, 3 feet plus. And we don't sell this as a flood-proof door because, in fact, there's still some water that trickles in through the bottom. In this case, we found that you could pick it up, cleaned it up with a mop, but we don't want to represent that it is a perfect waterproof door. Now, there are doors on the market that do give warranties, and you can put them in front of your regular door. If you don't have one of our doors, you can actually put in a flood-proof door, and that can save you thousands and thousands and thousands of dollars and all the dislocation that goes with it. So again, if you are going to look at your, there in many cases these can be retrofitted. You, as I said, put a check valve on your septic system. You can prevent damage. 99% of the flooding, or 90 plus anyway percent of the damage from flooding. Energy efficiency is another thing. I mean, with Trinidad has one of the lowest, or probably the lowest electricity rates in the Caribbean. I was just speaking to somebody in Barbados. They're about 6 times what as expensive. So energy is a much bigger deal. Same thing in Antigua and most of the other islands other than Trinidad. Nonetheless, electricity is still a large cost. And if you put the right glazing on, there's something called solar E, which reduces the heat gain by up to 50% and can reduce the overall energy consumption by up to 30%. So if you're air conditioning your bedrooms or whatever air conditioning, you can make a major difference. And typically this stuff will pay for itself in very short order. 2 or 3, 4 months typically is the payback period. And over a period of some years, it can actually pay for the entire windows and doors. So it also reduces the, improves the indoor environment because it reduces hot spots. And even if you don't have AC, it keeps the houses much more comfortable during the day. Mikey talked about picking sites where there are sound attenuation, or pardon me, where there are a lot of noise pollution. And so especially in bedrooms, you might have neighborhood dogs barking, street noise, shopping centers, schools, whatever it might be. And it's not necessary to put up with that. Certain laminate glass, such as stuff we produce, will reduce the sound transmission by 35%. So this is an actual demonstration of just what that reduction looks like. It's not doctored. So that's a 35 decibel reduction. And so again, well worth spending a little bit of money. Very often, if you use laminate glass, you get security, you get a whole lot of benefits. If it's solar E laminate glass, then you're going to get energy consumption reduction. You'll get security protection against earthquakes, or pardon me, not earthquakes, hurricanes and windstorms, and also noise reduction. So the last thing I mentioned is the aesthetics. You want to buy an attractive product that you're going to be proud of, and that it's going to look attractive and maintain its appearance over your lifetime. So the styles and the types should be appealing to the homeowner. That's why, as I said, one of the things that we do provide as a service. So even if you're going to go somewhere else, you might want to talk to one of our window and door consultants and get some input on what you should be buying. Also, I think you want a long warranty period so that you can ensure that there's no painting or low maintenance, and also that the product is going to maintain its value for a long time. And here's some quick examples of what homeowners found as aesthetically pleasing windows and doors. So what we'll do now, I think, is to do both the roof pole and no, I guess we did that. Sorry, the window and door pole, and then we'll open the floor to questions. So which material transfers the least amount of heat by conduction into the house? The first one. The characteristics essential for security and hurricane resistance. Sound attenuation. How much sound attenuation can you get? What about rubber gasketed windows and doors? And what about a special glazing? And just a few more seconds. Okay, so let's end this poll and share the results. So very clearly, UPVC conducts the least amount of heat. The other two are not even close. It's a multiple. So definitely UPVC has the least amount of heat conduction. And all of these things, in order to be the essentials for hurricane and security protection, are all of the above. Now, people who didn't pick all of the above at least picked one of them, so it was important. The sound attenuation, there is sound attenuation from sound-resistant laminate glass. There is a particular formulation that is necessary, and you can sometimes get both very good sound attenuation and also impact resistance. But the stuff we have is about 35 dB, it's very hard to get above 35 dB without going to special installation. And the first rubber gasketed windows provide absolutely no protection whatsoever for security or hurricane resistance. As I mentioned, even if it has laminate glass, the moment you take a shot at it and crack the laminate, probably crack the glass itself, the laminate then becomes extremely flexible. And so you can actually kick it in with your foot very, very easily. So I know people seem to, they're very used to gasketed windows, but if you do some testing, you'll see exactly what I'm talking about. So that pretty well brings our section to an end. And so, Sir Moya, do you want to take over again?
Absolutely, Terry. Thank you very much for your informative presentation. It was quite wonderful. And just before we close, I would like to, are there any questions? I'm just looking at the attendees chat. Would anyone like to share anything before I make my closing remarks? Looking for any hands raised.
I see there's quite a few.
All right.
Helen,
So,
go ahead.
all right. So I am seeing in the question and answer box, Gumati Jagnanan. This person is saying, elaborate of the flammability of UPVC, and is there a tendency for it to warp in prolonged direct tropical sunlight?
Okay, well, PVC itself, UPVC is not, it will flame, it is flammable if you take a direct torch to it. And so in the heat of a fire, major fire, it could melt and so on, but it will not sustain combustion like wood or most of the other materials. So as soon as the flame source is removed, then the flame will self-extinguish, because what happens is the chlorine in the UPVC mixture actually creates a thin protective coating and snuffs out any fire. And no, there is no tendency for it to warp in prolonged direct tropical sunlight, provided it is properly stabilized. Now, UPVC by itself, or pardon me, UPVC without stabilization is in fact subject to ultraviolet and can break down. But there are certain stabilizers. Titanium dioxide, for example, is one that when properly used, you can basically put it in the sunlight for 100 years and you will see no deterioration whatsoever. Now, a lot of the windows coming from overseas do not use adequate stabilization. And so they start to, because it costs more money, it costs money to stabilize the UPVC. So it looks fine on day one. So but within 2 or 3 years, it starts to turn yellow. And in fact, I've been in some, in the competitor's showroom in Dominica, where within 2 years, even the samples in the showroom was turning yellow. So you have to get the right quality of UPVC, and if you do, then it will not deteriorate, warp, or change for over 100 years.
All right. Thank you so much, Terry. Quite a informative response. Let me just look once again. So we have no more questions.